Welcome to our video on splitting of instruction, bytes in violation of code, execution, after replacing 5-byte instructions with 12-byte ones. In this video, we'll be exploring a fascinating topic in the realm of computer programming and security. As programmers, we often take for granted the underlying mechanics of how our code is executed by the computer. However, understanding these low-level details can be crucial in identifying potential vulnerabilities and optimizing our program. In recent years, there has been an increasing interest in exploiting vulnerabilities in software execution, particularly those related to instruction-level manipulation. One such phenomenon that has garnered significant attention is the splitting of instruction bytes and its impact on code execution when replacing 5-byte instructions with 12-byte ones. Byte byte 1. In this video, we'll delve into the world of x86 assembly language to explore this concept, explaining the intricacies involved and how they can be used for malicious purposes. To begin with, let's understand what instruction bytes are and how they're processed by the CPU. When you write code in a high-level programming language like C or Java, it gets compiled into machine code that consists of instructions, each represented by one or more bytes. These instruction bytes are then fetched from memory by the CPU, decoded, and executed. Now, imagine replacing a 5-byte instruction with a 12-byte one. On the surface, this might seem straightforward. Just update the bytes in memory. Right, however, things get complicated when you consider how instructions are split into smaller parts for processing. Modern CPUs employ various techniques to improve performance, such as pipelining and out-of-order execution. These optimizations allow multiple instructions to be processed simultaneously, increasing throughput. However, they also introduce complexities when dealing with instruction boundaries. When a 5-byte instruction is replaced with a 12-byte one, the new instruction can potentially overlap with adjacent ones in memory. This overlap can cause the CPU to misinterpret instruction boundaries, leading to incorrect execution or even crashes. But that's not all. There's another critical aspect to consider: the splitting of instruction bytes. When an instruction spans multiple cache lines, its bytes might be fetched and processed separately. In such cases, replacing a 5-byte instruction with a 12-byte one can result in the CPU executing only part of the new instruction, potentially causing unintended behavior or even security vulnerabilities. To illustrate this concept better, imagine a scenario where you have two instructions, ADX, EBX, a simple addition, followed by GEMP label, an unconditional jump. Suppose the first instruction is 5 bytes long and gets replaced with a 12-byte one. If the replacement causes the second instruction to overlap with the new one, the CPU might incorrectly execute only part of the GMP instruction or even skip it altogether. So what should you take away from this discussion? Here are the essential points. Replacing instructions can lead to complex behavior due to pipelining and out-of-order execution. Instruction boundaries matter, especially when dealing with instruction replacements that change the size of the new instruction. The splitting of instruction bytes across cache lines or memory pages can result in incorrect execution. In this video, we explored a fascinating topic at the intersection of computer programming, security, and low-level CPU mechanics. We delved into how replacing instructions with different sizes can lead to unexpected behavior and potential security vulnerabilities due to the splitting of instruction bytes and violation of code execution. If you have any questions or want to share your experiences with similar topics, please leave a comment below. Don't forget to like this video if you found it informative and subscribe for more content on computer programming, security, and related topics. Thank you for watching, and we'll catch you in the next one.